let's apply this to the same two examples that we had in that previous video. On June 21, for LA, how many hours of sunlight do we expect? Well, the deck angle of the sun on that day is 23.5. The latitude angle of LA is 34.5. So we put here 23.5, and then we put here 34.5. So let's see what we get. You got to make sure when you're calculating this that you are in degree mode. You get 0.4034. So this came out 0.4034. 1 minus that, 0.5965 times 24 hours, 14.3. So the number of hours of T sunlight, 14.318. When we did it as a circular Earth, I believe we got something like 15 point something hours. This is more realistic, a lot more realistic, which if you subtract that's going to be about 14 hours 19 minutes. 14 hours about 19 minutes. In reality, that's about what we get in LA. On summer solstice, the sun rises roughly about 5:45 a.m. and the sun sets about 8:05 to 8:10. So roughly speaking, that's the longest day of the year for LA for people in the northern hemisphere, and then for LA people that ends up becoming about 14 hours and 20 minutes to 25 minutes. 14, 20 to 25 minutes. So our equation works pretty well for the spherical Earth. Now, let's do the other example. We had given an example of a person living at a latitude of -25 degrees, and how many hours of sunlight would they get on December 1st. So if you go back to the video, to the previous video, and review that, we had gotten an answer of, it was December 1st, and it was a person living at a deck angle of -25 degrees. And we had gotten an answer of 14.28 hours of sunlight. So what does our new equation give for us? So we have to first calculate what the deck angle of the sun is on that day, okay? And then over 365.25. 360 times 334 minus 80 divided by 365.25. You're going to take sine of that angle times 23.5. So the deck angle of the sun is -22.131 degrees. Then you put that here. -22.131 degrees. So instead of taking tangent of 23.5, you're taking tangent of this angle. And then over here, you're taking tangent of -22.131. Then you're going tangent of whatever deck angle that city is, which we had said was -25. Okay? So, tangent of -22.131 times tangent of -25. No, the way that the tangent is, when you take a tangent of a negative angle, you will get a negative answer here. Negative answer here, negative answer here. When you multiply them, you're going to end up getting positive, right? Then you're going to take the cosine inverse of that. You're going to get 79 degrees. Divide that by 180. Now you get 0.439266. Then you subtract that from 1. You get 0.56. You multiply that by 24. You get 13.45. 13.457 hours. So that will be more realistic. So we had gotten 14.2, so it gives us an answer that's less. So if, for circular Earth, basically what's happening is that the ratio, okay, if you take a certain distance here, the ratio of the dark portion, the ratio of the light portion to the whole distance ends up being more than if you consider the full circle. If you take a full circle and take the ratio of the sunlight portion to the complete circumference of the circle, the ratio is not as big as taking the distance from here to here and then dividing that by the distance of the dark portion. So for a more correct version, the ratio ends up being less, and therefore the number of hours of sunlight ends up being less. So this is the true equation, more correct for any latitude on Earth and for any time of the year. Thank you very much.